and start the presentation here. And we'll pull up my slides presentation. Am I sharing the top screen? I don't know if I shared the right screen.
Yeah.
I think I shared my wrong screen. All right. Cool.
Yeah, we are able to see.
Awesome. Well, thank you guys again. Thank you. I appreciate the introduction. My name is Mitch Spano. I'm an application engineer at Google. And today we're going to be discussing pure unit testing in Apex. The idea here is we want to be able to move fast without breaking things. If you need to contact me after this session is complete, I've got my contact information located right here. Probably the easiest way to contact me would be on Twitter. I'm lucky enough to have a unique enough name that I was able to get my first and last name as a Twitter handle. So you can find me there. Forward-looking statement, in case you guys happen to be making any purchasing decisions, please make them based on currently available features. I'm not sure that any of us are in a position to be buying licenses, but if you are, and I say something that's not available on a platform, please take that into consideration when you are making your license purchasing decisions. So about me, like I said, my name is Mitch Spano. I'm an application engineer at Google. I've been in the Salesforce ecosystem since 2013. Got hired right out of undergrad. To be honest with you, I had never heard of Salesforce.com before I got my first Salesforce position. And now I've been in the ecosystem for over 8 years now. So I've been in quite a few different orgs. I've been a full-time employee. I've been a consultant. I've been an independent contractor because I started my own company. I've worked on many different projects and have been able to learn quite a few things over the past few years. And I'm really excited to share this particular topic with you about unit testing. So what are some of the things that we're going to take away from today's discussion? The first thing is that we're going to be discussing kind of an overview of unit testing. What are unit tests? How should we use them? And why do we even care about them in the first place? And I'll give you a little hint. It's not just to get 75% code coverage. We'll also dive into some of the unit test fundamentals. So what is the notation that is involved when authoring a unit test? What is the structure of a unit test? And then we'll also talk about some quality signals. So what are some things that make a good unit test versus a poor unit test? So you can, at a quick glance, know if you're doing a code review or if you're taking a look at the code that's in your system, you can know, is this going to cause me issues down the line, or is this well written and well architected? And then finally, we're going to talk about something that I think is pretty cool, performance when it comes to unit testing. So in the wider Salesforce ecosystem, we kind of have this status quo, and there are some issues with the status quo. We'll go over what those issues might be. We'll also talk about avoiding DML, why that's important, and some beginner strategies that can help you to do that. And then we'll also talk about dependency injection, which kind of goes hand in hand with avoiding DML. We'll give an example of dependency injection that that enables you to avoid DML. But these are some of the main topics here, and I'm really excited to share this with everyone. Before we get into the overview, though, I'd like to share a little story, and it's a story that is probably familiar to most folks on the call. And that is this: you're a developer on a project. You just joined the team. Maybe you have some experience, so maybe you're a technical lead or a senior developer. The business has come to you and they said, "Hey, we've got this existing piece of functionality. Can you modify it to do XYZ thing?" And you're confident, you're a good developer. You're investing your time into additional extracurricular tasks such as attending developer user group meetings. You're learning from the best. You've gone through all the trailheads. You're like, "Sure, I feel confident. I can do this." And you take a look, and the code is just a mess. It's an absolute mess. And you think to yourself, "I should probably clean this up." But then almost immediately after you have that thought, you have a different thought. And that's the thought of your manager saying, hey, wait, we've got a deadline. So what typically happens there is you choose to make the tiniest little modification that you can that just does exactly what the business is asking for. And then you kind of walk away from that particular component. So when the business asks you to do something and you take a look and you see that there's this kind of nonverbal communication that goes on where you express a little bit of hesitancy about modifying that component. Now, when you do that, it's very normal and it's very human. But unfortunately, what it does is it diminishes your stakeholders' perception of you as a trusted professional. Stakeholders expect that things get better before they get worse. Stakeholders expect that you have fearless confidence in your ability to change the system without breaking it. So what we want to do is we want to come up with a system that will give us that fearless confidence. And that system is testing. Particularly, unit tests are the first layer of the base of that system. So what are unit tests? Unit tests are, well, let's talk about a unit, right? A unit is the most fine-grained element of software that can be tested. And we can identify units within our applications by taking a look at the interfaces and the public methods that are available to us. Now, a unit test validates that a unit is working correctly. That's all that a unit test is there to do. So if you ever see things if you ever take a look and you're looking at a test that's written in a Salesforce environment that you happen to be working in, and it's doing more than just testing interfaces and public methods, odds are it's probably not that succinct or precise of a unit test. So how do we use these unit tests? Now, we're all familiar with the 75% code coverage requirement. So a lot of times we'll make our modifications, we'll get everything working, and then we'll write the unit test, get the coverage, and push it into prod. The thing is that unit tests are to be executed every single time a code change is proposed. And unit tests exist to be our North Star or our guiding light and an internal compass to guide all decisions and all code modifications made throughout the application lifecycle development process. They also have this added benefit that they serve as an automatic self-documentation tool for all of the code. So I don't know if we have any people on the call that like to play video games, but there's this classic dungeon crawling RPG game that I personally love. It's called Diablo. And it was built for the PC in 1996, and it was ported to the PlayStation 1 a few years later. And when they ported it, they accidentally included the unit tests in the port. And the unit tests were so well written that people were able to reverse engineer all of Diablo 1's source code just by taking a look at the unit tests themselves. So proper unit testing, not only does it provide this internal compass for you and kind of guide your development process, it's also automatic self-documentation. The act of writing unit tests will save you many, many headaches in the future because you won't need to dive through the code. The path to production has a few steps. We start off in a sandbox or a scratch org, and we'll build the features that we're interested in. Now, anybody, maybe just a quick check in the chat. I'll keep my eyes peeled for it. Is anybody using source control and doing a full-blown DevOps pipeline? Just add a little +1 or yes I am or whatever you need to in the chat. And if you're not, I would definitely recommend that you take a look and consider it. Not only will it increase your level of engineering prowess and skill, but it'll also increase your speed at which you can deliver. So let's just for the sake of this particular example, we're going to assume that you are working in a DevOps CI/CD type of pipeline. So you'll build your features in the sandbox or scratch org that you're working in. Then you'll create a pull request in GitHub, basically. And at the time that the pull request is created, that's when you should be running tests. So tests are a prerequisite to even, they should happen before the code review happens, definitely before the merge happens for sure. If you're on a team of mine and I'm a senior engineer and you ask me for code review and your code has not ran through tests, I won't take a look at it. Your code must run all tests and run them successfully as a prerequisite for code review. And if you're not doing this in your pipeline, I definitely would recommend that you do that. Now I said something a little bit nuanced there, and that's run all tests. The point of running a test is not to validate that what you're working on works well in isolation. The point of running a test is to make sure that it doesn't break anything else within the system, that the whole rest of the system is working well when your new proposed change is merged in, or when it does get merged in. So if you're using GitHub, I would recommend using GitHub Actions to kick off the automatic execution of your tests after a pull request is created. So as a team member, I create the pull request. I don't need to do any other additional actions. The robot takes over for me and it kicks off the execution of the tests. So why do we run these tests? The tests are about more than getting code coverage. Unit tests define the system's behavior. They are the low-level system specifications. Somebody should be able to get a really, really solid understanding of what your code is trying to do just by looking at the unit tests. Your unit tests should be written in a way that they can kind of give those clues. So unit tests, I think about them as the breadcrumbs that we leave for future developers on our project or ourselves in the future, right? Because sometimes I have to spin back up and, hey, wait, did I write this code? Oh yeah, I got to figure out how is it supposed to work. If you have the unit tests, then you can write them as if they were specifications. So for example, get calculated category should return north if the billing state is Minnesota. It's a very human readable name for a test. And if this test fails, we know, we can kind of gather what went wrong. Apparently, if this test failed, we didn't really calculate the category correctly for accounts where the state is Minnesota. Or something like this, insert account should fail if the billing state is not populated. These read just like requirements. And I would challenge you to take your requirements and absolutely every single one of them, try to write them as a unit test. They are the low-level system specifications. And if you start writing unit tests like this, you're going to set yourself and your future teammates up for a whole lot more freedom and autonomy because they won't need to worry about all of the legacy code that has been delivered in the past. So what are the fundamentals of tests? The testing pyramid. This is probably the most fundamental of ideas when it comes to testing our applications as engineers. There are unit tests, there are integration tests, and there are end-to-end tests. Just a quick check in the chat, +1, thumbs up, do whatever you need to. Is anybody running some Selenium or other WebDriver-based end-to-end tests of their application? If you are, that's fantastic. Selenium is a really, really powerful tool, but you might notice that it's kind of challenging to keep those Selenium tests up to date as you progress and as you make system modifications. Unit tests, on the other hand, are meant to be extremely, extremely cheap to operate, own, and execute. So a unit test is just the test of the public method signatures of all of the constituent parts of your application. And somewhere in the middle, we have an integration test. So an integration test is when one part of the system talks to a different part of the system. So it could be something like talking to the database, right? Your public method signatures that interact with the database are actually, if you write a test that does that, that's actually technically an integration test and not a pure unit test. So as we talk, as we continue on this discussion, we'll be talking about ways that we can focus on writing pure unit tests. Now, there are plenty of great topics that we can talk about as we move up the pyramid, but for the scope of today's discussion, we're just going to be talking about the base that is unit tests. So some things about test notation. You can look these up on Salesforce. This is well documented, but these are some things that are going to be important as you read tests, or if you're a beginner, these are going to be important pieces of notation to know. The @is_test annotation denotes that a method or a class is a test method or class. Private. By default, all tests should be private unless they're like a test utility. So by private, I mean even at the class level. So not only just the methods, but the class itself should be private. System.assert equals. Now this is the most important part of the test. When we write tests, we need to make valid assertions that the system behaves the way that we expect it to. So in this notation, assert equals object X, object Y, string Z. This means if object X does not equal to object Y, then we're going to fail the test and we'll print out the message that's defined as string Z. Test start test and stop test. I personally don't, I think that there's an opportunity to improve the notation here, because start test doesn't necessarily mean you're starting the test. Starting the test, what that means is that you're resetting the transactional governor limits. So if you needed to do any DML to set things up, you apply start test, your transactional governor limits will be reset for the scope of that test. Same with stop test. Stop test doesn't mean like the test is just stopped. What it does is it forces the completion of asynchronous apex. So if you had something that implemented the queuable interface or a batch class, you call stop test, and then it will force the completion of those things that would otherwise be completed asynchronously throughout the rest of the transaction. It forces all of them to complete right there, so the results will be available for you. System run as a user. This is important if you want to test that your application works well with different user personas. So how does this method work when I'm a system admin? That's one thing, but how does it work when I'm a standard user or custom profile or a different user persona that's defined via permission set assignment? Test visible. This one is important for the scope of today's discussion. Test visible exposes private or protected methods or variables as public within the context of a test. So you can have a private variable, and that means that no other class can see it. Only the object itself sees it. But you can put the test visible notation, so that way you could see and kind of peek into it when you're running a test and say, what is the state of that variable? Or if you have a private method, you put test visible on it. That means that you can call that method as if it was a public method within a unit test itself. Test setup is for setting up data, interacting with the database. So test setup is really for more integration tests than it is pure unit tests. And then is parallel equals true. This is important because if you're using scratch orgs for your development pipeline, this is a big win. Earlier, I said we want to run all tests when any code change is proposed. If you're working in a sandbox, that can kind of become cumbersome, especially if you have multiple team members, because in a sandbox, if you do like the validate, only deploy, and run all tests as part of your pre-submit, that means that you're going to have this sequential test execution, and your teammates are going to have to wait for the previous teammate's test to complete before theirs will get kicked off. Is parallel equals true is going to set you up for future success, because then when you do make that migration to executing your pre-submits in a scratch org, not only can you have everybody is running their pre-submits in scratch orgs simultaneously, the methods themselves can be executed in parallel within a scratch org. So if you're working in sandboxes and you have troubles waiting for execution of tests to complete, is parallel is true, will help you when you do make that transition to scratch orders for your pre-submits. So definitely recommend starting that as soon as you can. So what is the structure of a unit test? Here we've got a unit test for our useless string builder class. I don't know anybody who would use this class in a real production org, but it illustrates what the kind of constituent components and the structure of a unit test are. So here we've got our private test class. That's the useless string builder test. This is testing the useless string builder class. And here we have a test method. It's a private static void. Build should concatenate two strings together. You want the names of your tests to be human readable. And we configure our tests and we write them in a way such that we split them up into three separate parts: arrange, act, and assert. Arrange means set up in memory the objects that you're going to be using for your test. Here, we're constructing a new useless string builder called myStringBuilder. Act means make the method call that you're trying to test. So here, I'm calling the build method with hello and world. And then finally, assert. So we're using that system assert equals notation to assert that hello world is the value that's currently stored in response. And if this fails, then we'll say we failed to properly concatenate two strings. We don't need to know anything about the useless string builder's build method. But if we read this test, we could probably implement this method ourselves. This one's rather trivial, but it helps you to understand that the unit tests are the system specifications. And the unit tests define at the lowest level how the system should behave. So if all of these things are running and passing, that should be a very strong indicator and give you that confidence that you need to be able to say, yes, this proposed code change is safe. So what are some quality signals of a good unit test? We've already talked about one of them, descriptive. We want our unit tests to be human readable and have a descriptive name that says what we're trying to do and what is the expected output. So that way, if it fails, we know exactly where to look. If you get that call at 2 o'clock in the morning saying the system is not behaving the way that we expected, it's going to be really easy for you to dive back through the code if you have descriptive names for your unit tests. We also want them to be repeatable. A unit test should not depend upon the state of the org or who's running it or the way that metadata is configured, any of those things. You want your test to be repeatable, basically in any sandbox or any prod or any scratch org that you might run them in. You also want your test to have a single cause of failure. So if we go back one slide, this test can only fail if the string builder fails to concatenate these two strings. Now, this one is a trivial example, but in the future, and in a couple of slides, we'll talk about some nuanced examples that might expose additional opportunities for your tests to fail that don't have anything to do with the actual validity of the test. And finally, your test should be cheap. By cheap, I mean cheap to construct, cheap to execute. This is to enable us to run all tests when, as many times as we need to without having to wait. Unit tests are meant to be cheap, and we'll give a little bit of an example of how we can make them cheaper to execute in just a few slides. So, unit testing performance. This is really the important part, and well, all of this is important, but this is the part that I am most passionate about and I'm most excited to share. We've talked about it a little bit, but the successful execution of tests is a prerequisite for your code to move through your development pipeline. So we want our unit tests to perform extremely fast. We also have this unique dependency with the database. If we were writing unit tests in any other technology stack, we would not have this explicit dependency with the database. In Salesforce, when you're writing Apex, your Apex can just make a query inline within a method and just fetch those results and treat those as regular objects. That's not the norm in any other technology stack. So when we interact with the database within our tests, we're not writing pure unit tests. We're writing integration tests. And that's how they would be classified and executed on any other technology platform. Here within Salesforce, though, we have this unique ability to be able to interact with the database via Apex with such low friction that we kind of forget that there's a difference between a test that interacts with the database and a test that does not. So the status quo in the Salesforce ecosystem is that we insert records to set up data for our tests, then we call the methods that we want, and then we assert the values that that the outcome is what we expect. So in this case, we're just going to insert this case. But if you take a look, we're calculating the timestamp before and after, and we'll calculate the number of milliseconds that it takes to insert one case record. 197 milliseconds. It's a fifth of a second, pretty reasonable in terms of human time. But the thing is that this isn't an empty scratch work. And we all know that as your org gets more mature, and particularly as you add more automation on your S objects, that time is going to go up. As you add more synchronous case automation via trigger, process builder, flow, whatever, that's going to increase the amount of time that it takes for a case to be inserted within the system. So 197 milliseconds is as fast as it will ever be. It will never be faster than that. So while it might sound okay at the time that this is authored, just know that this will rot and this will not get better. This will get worse and worse unless you take some action to avoid that. Now, here is one way that we can increase the performance of our tests. We can avoid DML by using fake record IDs. So we've got a class called the test utility. We can get a fake ID for the case S object type. Now we'll go into this test utility in just a moment, but it returns a syntactically correct fake record ID. So you can use this and it won't cause any runtime errors like, hey, invalid ID of some string. And you can use this as one of many tools to help you avoid performing DML. And when you do this, here we're calculating the timestamp before, calculating the timestamp after. How long does it take for us to construct a case? 2 milliseconds. And this 2 milliseconds is going to be constant. It's not going to depend upon any future automation that we introduce within the org. Now, even if 197 milliseconds was, even if we were guaranteed that that would never go up, we're still 2 orders of magnitude faster by avoiding DML and just constructing in memory our record IDs. So, when we talk about running all tests as a prerequisite to be able to perform code review or merge a change, we can write a lot more tests if we write pure unit tests that don't interact with the database. And then we can construct our records, and these tests are so cheap to execute that I might just write 50 of them. I can write 50 tests, and they'll still be faster to execute than one test where I insert one record. And that's the real performance gains that we can see. And this is where it's really going to become impactful as your org gets bigger and bigger and your team grows and grows. If we go back, this insert statement is just going to take far longer than 197 seconds, especially as your org matures in age. So if you can avoid DML, this is one strategy that we can use to help avoid some of these long-term pains that come with executing all of our tests. We want to be able to execute our tests because that gives us the confidence to know that, hey, this proposed code change is safe to make to the contents of our repository. 2 milliseconds, pretty fast. So here is the test utility itself. What we're doing is we're just basically, we have a static number that just increments every time you call this method. And we get the key prefix. And then it's like, for example, case is 005. So it'd be like 005, a whole bunch of zeros, and then 1. And then the next time I call, it'd be like 005, a whole bunch of numbers, and then a whole bunch of zeros, and then 2. This will produce a syntactically correct fake record ID for you to use within the scope of your test. Here, we denote this as is test, but public. The reason why we do that is because then other test methods can call this. It's still a test method, though, so that means it can't be called in your production Apex, but this is a test utility. It's meant to be able to provide utility for all test classes that are using it. So another thing that we want to talk about is when in doubt, mock it out. So we can use fake record IDs to construct in-memory objects. That's cool. But what if what if my Apex actually ran a query? So what if I had an account controller and it had this public method that returned to me a string called get calculated category from a record ID. And we can see here by this this class diagram that we have this private method get account from ID, and then we have this private method get category from account. So you can kind of imagine that, okay, this get calculated category method is probably going to call get account from ID, and then based on the result of that, it'll get the category from the account, and that's what it's going to return. Then we have our corresponding test. Get calculated category should return north if billing state is Minnesota. So this is something that we would expect to see if we're writing a controller for any kind of Lightning Web component. And this is very normal in the Salesforce ecosystem. So here is how we traditionally would write a test for this, right? I would follow the arrange act assert protocol. I would write a descriptive name, get calculated category should return north if billing state is Minnesota. I would construct an account controller. I would create a test account and I would insert it. And then I'd give this method the ID of that test account and assert that north is the category. This is normal. This is exactly how we have always done it in Salesforce. This is a pretty good test. It's very simple to read. It's partitioned into arrange act assert. It's got a single point of failure, but wait, does it? When we insert this account, not only are we slowing down the performance of this test, this is not a pure unit test because this does not have a single source of failure. When we insert this account, we're absorbing the responsibilities for any validation rules, any process builders, any trigger code. All of those things must execute successfully. And if any of one of those fails, this test will fail and it will have absolutely nothing to do with the calculation of the category. So you could get a failure and you don't know exactly where to look. It's not a pure unit test. This would be an integration test for this particular piece of functionality. But how are we supposed to test this functionality if this get calculated category just accepts a record ID and it needs to perform a query? This is where we can mock the query results. And we're not going to be talking about the out-of-the-box or standard mock or stubbing utilities that Salesforce provides. This is a very easy way to mock your query results. Here we've taken the existing classes that we have, the account controller and the account controller test, and we've introduced an inner class called selector. Now this selector, you can see it's got a virtual account, get account from ID, record ID. So you can imagine that this account controller's class, when the private get account from ID method is called, it's going to use the selector class to perform that query, and then it'll return the results. And we can have this test visible notation on the private instance of the selector within the account controller to allow us to fake out or mock the results for the selector. In this case, we introduce a test, an inner class within the test itself called fake selector. And we can override what gets returned when we call the get accounts from ID. So this class diagram is a little bit, it's a good example, but let's dive into the code and what does it actually look like. So we can imagine that this private method get account from ID would use the selector, an instance of the selector, to call that method, maybe do some other things, assert that it's a valid record, throw some exception, do whatever else you need to do. And this selector class is a private virtual class that's within the account controller itself. And this basically acts as the insulating factor to insulate your controller logic from interacting with the database at all. So in this case, the selector class is just responsible for querying for the account that matches this ID. Now, when it comes time to execute a test, and we don't want to insert a record to make sure that we have an account to calculate the category for, we can use this fake selector. So this is an inner class to your test class called fake selector that extends the account controller selector. When we extend the account controller selector, we can override that virtual method called get account from ID. Here, what we're doing is at the construction of the fake selector, we inject an account that will be the response for when get account from ID is called. This is dependency injection. The account controller class depends upon the existence of an account object, and it must fetch it from the database. So here we're saying, okay, you don't need to depend upon that now. We will give that to you, and then you can do with it what you need to. So this is one good example of how we can inject the query results that we expect and write a pure unit test that'll execute extremely fast. So when we go back to our test, get calculated category should return north if the billing state is Minnesota. Okay, what we're doing here is we are mocking an account with a fake ID and mocking the selector for the given controller to be this overridden fake selector. So this means that when the controller under test calls get account from ID, it's just going to return the mocked account. We haven't even inserted this account. It's just got a fake ID. But we can pass that fake ID into the method call itself, and we can calculate the category. Then we can assert that the category that we expect is north. And if it's not, then we've done something wrong. This is a pure unit test. Now, the only way that this can go wrong is if the get calculated category method is written incorrectly. So these tests, they're super, super cheap to execute. They can operate in single-digit number of milliseconds. So while this does not absolve you of all responsibilities for ever inserting an account to test. This is just a way that you can write a pure unit test and write 50 of them, write 100 of them. It's going to be so cheap to execute that you might as well just really, really cover your logic from every single angle that you can think of. And when you use these types of strategies to avoid interacting with the database, you can then unlock that level of confidence because you are able to execute all of your tests in a reasonable amount of time that doesn't become a hindrance. And you can know that your logic is written very well. So this is one particularly easy to absorb example of a way that we can inject our dependencies, in this case, we're dependent upon the existence of an account, into our tests, execute our tests, and assert that all of our logic that populates or extracts variables or does whatever it needs to do with that account executes the right way. So my challenge to you all is to try to test absolutely everything without DML. So in the scope of this discussion, we've talked about how can you avoid insertion of a record? You can use a fake record ID. That's a nice way. How can you avoid insertion of a record for the result of a query? You can use a fake selector and inject the query results at the construction of the selector to be able to do that. But that's not everything, right? There are some other things that we can do where we can improve the quality of our unit tests, pure unit tests here, in a way that will allow us to write hundreds of tests and execute a plethora of tests from every different type of logical angle on our code that does not become a hindrance to running those tests as a prerequisite because they perform so fast. So my challenge to you is, we already talked about using fake record IDs. That's great, super helpful. We already talked about using injected SOQL query results, super helpful. You might be able to, and in fact you can use test utilities to set values of read-only fields. So if you had, say, a formula field that traversed an object relationship to calculate its value, in the normal integration test way, you need to insert the parent, insert the child with the relationship, and then you'd be able to have that formula value expression for you at runtime of test. My challenge to you is try to figure out a way where you can construct in memory objects where you can write those read-only fields. It's possible. Another thing that you can do is set child relationships. So if I have a query that's my account with all of the related contacts, select ID name, comma, select ID first name, last name from contacts from account. Using the normal Salesforce way, you need to insert the parent account, insert the child contacts, and then execute the query. My challenge to you is to try to figure out a way where you can set those child relationships in memory. And then you can use those objects that you create in memory and inject them in to your SOQL query results. So that way you don't need to insert the parent account or child contacts. And then finally, you might notice we've been talking about query results and creating records, avoiding hitting the database. That's just for like fetching. But what about insertion or updating? I would recommend create a DML class where you can override and use a mock DML instance in your Apex such that you can write tests, and then you can tell it, okay, when I insert this record, I'm going to inject, or I'm going to forcefully return a database.save result that is not successful. So that way you can test, how does your application behave when a validation rule, for example, hits. You don't need to actually go in and find an existing validation rule and set your test up and insert the record such that they trip up that validation rule. You can inject your database.save results using a mock DML, and then you can assert that your logic handles that the appropriate way, all without ever even needing to touch the database. So these are some things that I'm really excited to share with you guys, really excited to share with the wider Salesforce ecosystem, because as your organization matures and as you move more towards the future generations of DevOps, CI/CD, continuous delivery, doing things as fast as you can without making any mistakes or breaking anything, all of these little bits and pieces are going to be applicable tools to help you run those tests in an expedient manner that does not interfere with your ability to deliver. That is the presentation. So I want to say thank you guys for coming out and checking out, listening to this presentation. I'm super excited. This is a topic that I'm really passionate about, and I'm opening up the floor. If you guys happen to have any questions, now would be the time to ask.
If you guys have any questions, you can use the chat window, or I can turn on the mic for you guys if you want to ask any questions.
Cool. We'll also testing batch jobs when we use this approach. So testing batch jobs, that's a great question. So if you take a look within the batchable interface, there is a when you implement a batchable job, you there's an execute method which accepts a schedulable, batchable context and the scope. So you can test that the execute method of your batch job runs exactly how you would expect it for the given scope. So that would be an applicable pure unit test for a batch job itself. It's just executing when you can just pass in null for the batchable context and then pass in whatever objects you want. Um, area you suggest start with small, something like this. I definitely would recommend first thing is remove your dependencies. I would try to isolate your SOQL queries in private, virtual, inherited sharing selector classes within as an inner class within the class that you're trying to author. That I think is the easiest way to get started with this because then you can inject those query results at the time of your test. How can we cover automations on CRUD using this approach? So going back to this challenges slide, mock DML is going to be the place where you can in memory instantiate database.save results or database.delete results, or I think there's a database.insert result. There's all those database save result style objects that are returned when you call database.insert, .update, .upsert, .delete. Construct those in memory. So that way when you and use a mock DML object that you can inject in your tests, so that way you can get all of your logic done, and then at the very end when you need to perform your DML operation, your test doesn't perform the DML. It just it receives those injected database.save results that you told would be you told the test to expect to be returned at test execution time. Examples on GitHub, not yet. I, as a Google full-time employee, must be extremely careful about what I can and cannot do in GitHub. So I will actually be taking the contents of this topic and I will be putting it on my personal website. I got this awesome website, www.mitchspano.com. I actually built this all using, it's built using open source Lightning Web Components, Heroku, and Node.js. So I'm kind of proud of it. I'm going to take this opportunity to, try to drive some traffic to my own personal website. But I will be putting this content up in a blog post on that website. Probably, I've got some family coming into town this weekend, so I'm not going to guarantee it'll be done by this weekend. But within the next couple of weeks or so, this should be available publicly for everybody.
I think that should be our next topic in this group to discuss how you build, and it will be great learning for everyone.
Yeah, maybe
Yeah,
we'll talk about.
personally, I learned about your website, so then only I just contact you. So that was really great to learn that you build entirely on this Lightning Web Component and Heroku. Yeah.
Yeah, I'm as a Salesforce engineer, like I said, I got hired right out of undergrad, started working in Salesforce. So I'm kind of a one-trick pony. Like I don't know very many other technologies as well as I would like. So I tried to build my own website um, as just a fun opportunity to learn more and become a better engineer.
Great. Thank you, Mitch. Like it's really a wonderful presentation. It gives like a great insight about how we can write the unit test and improve the performance. I just learned a new perspective of writing in a unit test class. Actually, it's really a wonderful presentation. Thank you so much for joining today. And for the attendees, we are having like an next upcoming session, which is on the November 3rd for the combined third annual career event. So like, and I will be sharing that event link after this meeting, so you can sign up and join. And for any upcoming events, like if you like to present or if you like to share, please feel free to reach out to me. I will be reachable through Twitter, or you can send an email through the Trailblazer community group. Thank you. Thanks a lot. Thanks once again, Mitch, and thank you all for joining today. See you all in the next event.
Awesome. Thank you guys so much for having me. I really appreciate it.
Thank you.